Welcome everyone to a new learning journey. So I would like to call this as learning Java with data structures and algorithms on Azure Cloud. Or I can even rephrase it as learning Java with data structures and algorithms on cloud. And since we are doing it in more of a IAS or a pass way of doing rather than serverless in this particular series of classes, we can easily migrate these things from one platform to another or one cloud to another. Since we are especially using Spring Boot based applications, we can easily move it from one platform to another or one cloud to another. I am assuming you have already gone through the previous episodes, including before cloud and all, where I had mentioned about different service models on cloud, like IaaS, PaaS, serverless, etc. If not, you can go back and watch it. Anyway, that does not have much impact on this course. But in today's world, you cannot survive without a cloud. Many people actually ask me, I am into an administrator stream, or I am into a non-programming stream. I am into DevOps, thinking development is not my cup of tea, or development is something that is going to be very difficult for me. And some people have also said, I have tried learning development in college, but I was not very good at it, so I could not learn. And some people also said, okay, I tried learning from YouTube videos, I tried learning from books, I tried even learning from some courses. My advice to all of you is, if you have not learned from me, you can at least give a try. And if it is not working out, you can surely go with other tracks. But I personally believe that if you put effort, you can definitely learn it. So you don't have to be an expert. At least a basic or very good, decent understanding of the development practices is very much essential for any roles for that matter. Just take the example of an architect. If you are looking into an Azure architect, for example, and if you look into the Azure architect, solutions architect certification syllabus or the certification page in Microsoft portal, so you can see that it mentions to be an architect, you need to have development experience also. Consider DevOps. The term DevOps itself is coined from dev and ops, right? So if there is no dev, there is no DevOps. Just imagine if people are not developing software, then what is the point of deploying it? What is the point of building pipelines? So everything is dependent on development, and hence you will definitely have a lot of opportunities in development for a very long time. Okay, so that said, we can get started without much delays. What we will be learning is not going to be just Java, because we will be also learning data structures, algorithms, and many things I have been talking again and again, right? So what are these things before going into Java? So data structures, to understand, you need to understand a few more things, few more basic concepts, and then data structures are nothing but implementations of those concepts in your programming language of choice. Today, we are not going to start with the data structures, even though everywhere it is told as data structures and algorithms, data structures and algorithms. But we are going to start with algorithms. We are not going to stop with these algorithms and data structures just after today's class. All throughout our Java journey, we'll be practicing these algorithms, practicing working with algorithms, practicing working with data structures all throughout the course. The reason is because then you will be learning two things at a time. So you'll be learning data structures, and also you are practicing it using Java. So you'll be learning Java also. So you'll be learning Java as well as data structures. And finally, we will be learning all other required things such as Spring Boot, and then we'll be also doing a live project. And I believe if you follow all these things, seriously, you will definitely love programming or love developing applications, and then you can become a programmer. And then even if you do not love all of it, at least if you have a decent understanding of these things, then you can even be a good DevOps engineer also. The more you do problem solving using some programming language, your brain capacity will increase. So you have to think, you have to build solutions. It is not just following up something that we have learned and just doing creating a pipeline again and again, or implementing something or administrating something. So all those things are or will become repetitive after some time, and then you don't need a lot of brain power to do those things. But to actually develop applications, you need some brain power. And the more, it is just like doing exercise for your body, right? The more you exercise, more you do exercise for your mind, it is going to be really great for your brain power too. Okay, so we will continue to do all these exercises, just like we will do exercises in gym for our body. We will try to do more exercises using data structures and algorithms in our Java programming course, and we will be learning all of those things together. I will make sure that all of you are going to love this programming journey. If you have any doubts, queries, or if you feel like you are slow, I would be happy to spend extra time to get you into speed along with the others. Okay, any quick questions before we start with actual topic for today, which is going to be algorithms. Let me share my screen. Before learning Java itself, or even if you know Java, or even if you are learning Java, so this session is for all of you. So let us start with algorithms. Okay, tell me in the chat, what are algorithms? Just your version of definition for algorithms. So if you are actually participating completely 100% in this session, you are really going to learn. Okay, so a sequence of steps to solve a problem, a process, a set of rules, a simplified approach to solving a problem, step-by-step procedure, steps to perform a particular function. In simple terms, an algorithm is a set of instructions to be followed to solve a problem. An algorithm can take one or more values as input, and it will provide one or more values as output. You can implement these steps using a programming language so that it will be understood by a computer. So rather than directly jumping into programming, it is always good to write down the steps needed for that program in plain English, and then you can implement it using any programming language of your choice. And then another important term that we may come across is pseudocode. What is this pseudocode? I want you to type, because programming is all about typing, right? Steps to follow it in a simple language. It is template for program. Steps without a specific language syntax. There are a lot of definitions coming up in the chat. We can define pseudocode as a high-level description of steps that are provided in an algorithm. Pseudocode often uses structural conventions of a programming language. What does that mean? So pseudocode uses structural conventions of a programming language, but is intended for human reading rather than machine reading. Algorithms are just steps like algorithms are just steps 1, 2, 3, etc., etc. But pseudocode could be following any programming language. So like for I int I. So this is more like a programming language, or you can say it will be more similar to, or you can say for I in set. So there is no proper definition, but again, it will be following some programming language, whatever programming language you are going to do, or it could be very close to a programming language, and it is somewhere in between a programming language and algorithm. But again, in general, there won't be like steps like 1, 2, 3. It will be more closer to a programming language, and then it may not compile, or in most cases, it will not. Okay, it will not compile because it is intended for human. Because your goal is not to make that program execute, but to make sure that you have got the logic correctly. Okay, so it will abstract away all those programming constructs or syntaxes that are confusing, maybe, because you can substitute it with anything that you want, as long as it is closer to that language, uses important constructs, and then you can make sense out of it. So next problem is, imagine that we have an algorithm, we have implemented pseudocode, or we may have even implemented it as a program in a language and executed it. An algorithm could be implemented in different ways, or for the same problem there could be multiple algorithms. How do you decide which is the best algorithm for a particular scenario? And for that, in computer science, we do something called as algorithm analysis or analysis of algorithms. What do you think is analyzing algorithms or algorithm analysis? Have you heard about anything? Do you know anything? So anything you can mention just in a line. Okay, time and cost, complexity, memory usage, time usage. So analyzing algorithms involve how their resource requirement will scale with increasing input size. So whenever size of input is increasing, how will your program perform? How much time will it take? How much space will it take? Generally, when we calculate the computational efficiency of an algorithm or program, so we tend to consider time and space. And when you start, it is generally a practice to start with time, unless there is a specific requirement to take care of space as priority. Because sometimes you may have to do some trade-off between time and space. In that case, based on your need, you will have to choose. Because if you are writing a normal program, these days the space is less costlier than your computing. How do you calculate the time efficiency and space efficiency for algorithms? So we are doing this upfront because whenever we are doing a program or algorithm or pseudocode, we will analyze those algorithms. So rather than, because many people, what they do is when they learn Java, they start learning Java, and then they complete learning Java, then they start learning data structures and algorithms. And then after all these things, they will start learning analyzing algorithms. So these are all people who are focusing on interviews or doing all these things for interviews. But if you are doing all these things together, then whenever you are doing a program, even if it is for a learning purpose, then you can analyze those things, algorithms or programs, and then you can say, okay, if it is a good algorithm, is it efficient? So those efficiency is calculated using some techniques. Okay, how many of you can know about those techniques or want to share something about those techniques? So what is that analysis process called? So it is generally referred to as asymptotic analysis. So what do you mean by asymptotic analysis? Let me give you an assignment. So if you Google for the meaning of the word asymptotic, what will you get? Okay, the word asymptotic, the literal meaning of the word asymptotic is approaching a given limit, usually infinity, but without touching it. Okay, so it is kind of approaching something, approaching a limit. In most of the cases, it is infinity. You cannot really reach infinity, right? So you will be approaching it, but without touching it. With respect to algorithms, so we will be using that in our algorithmic analysis. But again, the real theory behind asymptotic analysis itself needs a separate class, and some of those things will be mathematical. And unless you are going to do good research on algorithms, you can definitely look into just what is needed for your programming class and then leave the rest. So if interested, there are a lot of good books. I had shared some of the books in the chat earlier. So if you are interested in learning, you can read more of them. But for our program, for our learning program, that is not needed. Okay, so when you say asymptotic analysis, there are three important notations that are important. And one is called big O, denoted as O, and omega, and theta. Okay, so symbols may change a bit here and there. Okay, so there are three notations. Okay, big O, omega, and theta. Big O, if you consider big O, it is used to calculate the upper bound of an algorithm's running time. It is used to calculate the worst case complexity. Okay, omega, it will be lower bound. Lower bound means it will be best case complexity. And finally, theta, it has both upper and lower bound, and it is used for average case, or as you people say, medium case. So you can have worst case, you can have best case, and you can have average case. So when we do a time analysis, which of these do you think should we use? Should we use worst case, or should we use average case, or should we use best case? In general, the worst case analysis of an algorithm has found to do a reasonable job of capturing its efficiency. An average case, the problem is that average case has to be done over random input instances, right? So you because you are going to tend your input is going to tend towards infinity, right? So you cannot have all values, so you have to choose some random values, and you will be using those random input instances to calculate the average. So this random could be biased. So with many reasons, and with many trial and error and many other experiments, it is found that worst case analysis is generally better. Which of these big O or omega or theta, which of these we will be using for worst case? Yes, big O. So that is why in most of the algorithms, algorithm analysis, you will see okay, the complexities such as O of 1, O of 2, O of 3, no, O of 1, O of n, O of n square, etc. We will be also using big O for our algorithm analysis. So going forward, we will not be discussing much on the other areas. And we will also not go much into serious proofs and theorems with respect to these things, because this is a fundamental course. But if you are interested, then maybe in future we can go deeper, because in my master's we had a lot of drilling down into many of these things using something such as master theorem and all those things. Vinith has asked, can you explain why these are helpful? I'm not getting much. Definitely. So now that is a very good question. Why analyze using big O or anything? You have a program 1 and you have program 2. How will you see which of these is better? Because your a single problem may have multiple solutions, multiple algorithms. Even a single algorithm may have multiple implementations. How will you decide which of these is better? one solution is definitely to execute them in a computer. Can somebody tell me whether that is a good solution or executing both of these is in a computer? For if you have only two algorithms, it is fine. Okay, so if you have only two algorithms, it is fine. But the problem is if you have many algorithms written by different people. So for example, if I am writing an algorithm sitting here and you are writing another. So in this case, the environment on which these programs are executed also matter, because I am writing a very bad code and I have a super computer, and if somebody else is writing a very good code and they have a very bad computer, so my program may look as if it is good. Okay, so this big O or other notations are used to make sure that okay, you can analyze algorithms and give them a score or give them some I will use very simple terms. So give them some score or ranking or something, okay, something to compare them, okay, whether this is good or that is good. And for that, so to better understand, because I have just mentioned so many terms, right? So you will understand it better if you take some examples. And before going into the examples, you have to learn one more concept called order of growth. Anybody know what this order of growth is? Okay, you may not be getting all of it today. You may have to also read a little bit of these terms that I am talking, because and then you have to come back with doubts, or then you have to even if you have understood more, then you can explain it to others in your own way. That is how we used to learn things in colleges, right? Our instructors never used to teach us everything. We also used to learn and teach others. So I used to teach a lot of people. Okay, so now order of growth is a set of functions. Again, so function, it is bit mathematical, for which the asymptotic growth behavior is considered equivalent. Okay, for example, if I have so 5 into n, or 500 n, or n plus 5. Okay, so all these are considered equivalent in terms of asymptotic growth. Okay, so when you give, so if your program has a statement that contains 5 into n, so n is the input size. Okay, so n is the input size. So whenever you are considering analysis of algorithms, you consider input size. So here, so 5 into n, you have a statement which multiplies n by 5, or 500n, or n plus 5. All these are effectively same from the perspective of order of growth, because for smaller values, these may have different results, but when it comes to very large values, these are almost similar if you plot them on a graph. All these things can be considered as or represented as order of n. Similarly, if you have something such as 5n square, or 500n square, or n square plus 5, then it will be order of n square. And then if you have something of n cube, it will be order of n cube, and so on. Even if you are not, even if you have not learned a programming language. So let me show you a simple programming construct called for loop, where the statement will be executed n number of times. Okay, so consider this: for int I equal to 0, I less than n. Okay, and then I am doing I plus plus. What will be the complexity of this algorithm or this for loop? So here, this statement will be executed how many times? That will give you the answer. How many times? N times. So the complexity is order of n. Okay, let me explain the concept of that worst case and all. Okay, so imagine that I have a array or list of numbers, say 1, 5, 7, 6, 2, 3. If I am searching and then here n equal to 1, 2, 3, 4, 5, 6, 6. Okay, so if I want to search something in this list, what will be the best case? Best case will be 1. So if I'm searching for 1, that is the best case. So average case will be somewhere in between, and worst case will be n. Okay, so if you are going through this, the worst case is going to be n, right? So if you are using a for loop to actually find whether whatever I am searching for is there in the list or not, the worst case is going to be n, right? Can everybody agree to it? If you are not clear about it, then I will explain it, because at least this clarity is needed for understanding the rest of it. Do you agree that the worst case is going to be n, best case is going to be 1, and worst case is going to be n? And hence, so in our algorithmic analysis, we always look for the worst case, right? So whenever you have a loop, the worst case is that whatever be the logic, maybe in best case, you may be exiting that loop before reaching n. But in worst case, you will be executing this statement or whatever statements inside this for n times. Okay, so here, if n is going to be 5, then you will be executing it 5 times. Let me give you another example. I say for in I equal to 0, I less than n, and then inside that I have another for int j equal to 0, j less than n. And then you have I plus plus here, j plus plus here. So if the value of n is 5, how many times will this code get executed? So this is inside this, so this is inside. So if I have some line of code here, how many times will it get executed? So let me see your mathematical skills. It is n square times, which is 5 into 5 equal to 25, right? So worst case is n square here. So the complexity of this one is order of n square. Clear until now? Okay, how n in n square? Okay, how n square is your doubt, right? Okay, so tell me. Okay, so forget about n square and all those things. How many times will this get executed? Okay, so this is a for loop, right? So what do you mean by loop? Okay, loop means, so initially, so I will just show it here. So initially, I will just explain it here again. So you have for int I equal to 0, I less than n, I plus plus. You have for int j equal to 0, j less than n, j plus plus. Okay, first what will happen? So this is important to understand even how loops work. First, what will happen? First, what will be the value of I and j? And here I am just printing I and j. Okay, this is not any programming language, so consider this as a pseudocode. Okay, so what will be the value? So first, so tell me what will be the value that will be printed first in this case? Okay, it will not be 0 because I am printing two values, right? It will be 0, comma 0. Till that it is clear, right? So now tell me what will be the second value that will be printed. That will make things a little more clear. Second value will be 0 because so how a loop work is, for every input, so for I equal to 0, this inner one will be executed. And so this inner one, once you come into this inner one, so for this inner one will be executed for this condition. Okay, so for so outer one will be I equal to 0, and then inner one will be 0, 1. So this will be executed n times. Okay, so forget about the outer one now. So for every outer iteration, so every time you go through a loop, it is called an iteration. So for every outer iteration, the inner one will get executed. So for first, when I equal to 0, the inner one will get executed. How many times? N times. So when I equal to 1, again n times. I equal to 2, again n times. So that is what? So, and so I will be sticking as 0 and this n times. So 1, so second time it will print the 0, 2, third time it will print the 0, 3. So this, so I will be, so this I will be of outer loop, right? So outer loop, you are now at 0, and for every input in outer loop, your inner loop will execute from 0 to n. That is, if your outer loop size is n and inner loop size is again n. Okay, so for clarity, we can call it as m. Okay, if your inner loop size is m, then how many times this loop will completely get executed? It will be n into m. And if both of these are n, then it will be n into n, which is n square. So the only thing you have to understand is so loop means it will execute n number of times. So the outer loop will execute n number of times. Each of those n number of times, the inner loop will execute m number of times. So the total number of times this will be executed is n into m. And if n and m are both same, then it will be n into n or n square. Is it clear now? Okay, understood. Thank you. Clear. Okay, so now you are clear about this one, n square. And another important thing is if you have a constant. So for example, if you have 5n, so not 5n, if you have something like a 5 or 6 or 7 or whatever it is, if you have a constant, then the order of complexity is generally referred to as order of 1. Okay, can we use real values? Yeah, you can use real values so to understand, but whenever you are comparing algorithms, then you mention as order of n. So that is why I mentioned, right? That is why it is called as order of growth, because all of these things are considered equivalent. So in order of growth concept, so 5n or 500n or even 7n, all these things are considered equivalent. So these real values can be ignored when we mention the order of growth, because for smaller inputs, it may make sense. Okay, for smaller inputs, it may make sense, but for larger inputs, it will be different. For example, if you consider 5,500n and 5n square, which is going to be a good algorithm? Tell me, 500n or 5n square, which is going to be a good algorithm? Okay, all of you are telling 500n, right? So initially, just assuming that, just assuming that 500n, so every iteration will take 1 second. So this 500n, so this statement, and if n is 1, then this statement will take 500 seconds. And this statement, 5n square, will take, so if n is 1, then n square is 1, and then it will take 5 seconds. Okay, so all of you told me that 500 seconds is better than 5 seconds. Why? Because for smaller values, you may get a feeling that, okay, this is better than the other. But if you plot these things in a graph, this 500n might go like this, and the other one, this 5n square, may start low, but after some time, it will exponentially go. Okay, so that is why you have a table of order of growth, which says, okay, which list down most of the common ones and how their performance is compared against each other. Okay, I will tell you that table. Okay, so first one is order of 1, which is called as constant. And second one is order of log n. So we have not seen log n. We will see it now. That is the only guy which has a little bit of confusion, which is called as logarithmic. And third one is order of n, which is called as linear. And then you have order of n log n. Then you have order of n square, which is called as this is called as n log n itself. There is no name, I believe. And then you have n square, which is called as quadratic. And then you have n cube, which is called as cubic. And finally, you have order of c raised to n, which is exponential. Okay, so this is just a table to compare among. So you can see that, okay, if you figure out that, so we will learn how to figure out which of these. And once you know that, okay, my algorithm is order of 1 or order of n or order of log n or order of n square, then you know how to compare. Okay, with and one is order of n and one is order of n square. Then you know that, okay, the one with order of n is going to be better. Okay, understood until now? Assume that you know calculation. You know how to calculate these perfectly. Assume that you know how to calculate these perfectly. Then can you use this table to compare and find out which is the best algorithm? Yes or no? Yes. Okay. So assuming that you know how to calculate. Okay. So now you have seen. I will give one more example, and you have to tell me which of these it belongs to. Okay, so everybody has to practice on your own, and then let me know. Okay, are you ready for the challenge? Okay, if you provide the right answer, then you can start your Java journey immediately. Okay, so what example will I give? For I equal to 0, I less than n, I equal to I into 2. Tell me. You may use paper and pen and paper. Tell me whether it is which of these. It is order of 1 or log n or n or n log n or n square or n cube or c raised to n. Which of those order of growth does this belong to? Okay, I need answers. Okay, there are answers such as order of c raised to n, order of log n, even number, order of n. So so this is one very special case which you have to understand. So there is also an answer of order of n square. What is the worst case? Worst case. Imagine that your n is 5. N is going to be 5. You will start with I equal to 1. Okay, that could lead to infinity loop. Okay, so I have corrected it. Okay, so now imagine that we are starting with 1. Thank you for that, Samik. Imagine that we are starting with 1. So in first iteration, I will be 1. When you start, I will be 1. And then you do I equal to 1 into 2. I will become 2. Next, what will I become? So I was 1 initially. In first iteration, it became 1 into 2. Second iteration, it will become 4, right? So it will become 2 into 2, which is 4. And third iteration, it will become 4 into 2, which is 8. And 8 is greater than n. So this will come out. So the answer is definitely going to be less than n. So your basically it is doubling every time. So every time your I is doubling. So answer is definitely going to be less than n. So that you have that you are clear, right? Answer is definitely going to be less than n. Agree to that at least. So now, so then if you do not know much of mathematics, then you can guess in most cases that, okay, or you can consider that, okay, if it is doubling, or so one case is so one situation is your I is doubling, or another case is your total n is getting half. Okay, in any case, you will have similar situation. Okay, so but forget in both of those cases. Let us consider one thing. Okay, imagine that we have k steps, and then in first step, what will happen? It is 2 raised to 1. Second step, it is 2 raised to 2. Third step, it is okay. No. So this is 2 raised to 0. This is 2 raised to 1. This is 2 raised to 2. And this is 2 raised to 3. Okay, so people who are not from mathematics background, excuse for just a few minutes. Okay, so people who are from mathematical background know these things, right? So whatever I have mentioned is correct, right? Okay, so 2 raised to 0 is 1, 2 raised to 1 is 2, 2 raised to 2 is 4. So like that, you can write. If you have k steps, so in the kth step, 2 raised to k equal to n. 2 raised to k equal to n. So definitely your result is going to be less than n. Okay, clear until now? Okay, so yeah, so we are going to that step, Varun. Yeah, you are one step ahead. Okay, so clear until now, right? 2 raised to k equal to n. Okay, so now for people who know about logarithm, so if you take a logarithm on both sides, what will happen? Log of 2 raised to k equal to log of n. Okay, so we have just put log on both sides. And again, if you know logarithm, so then you can know that I can write this left side as k into log of 2 and right side as same log of n. And now if I assume that, okay, the base for this logarithm is 2 in both cases, then this will become 1. So it will be k equal to log of n for any base. Okay, so we can derive that. Okay, this is going to be a log of n. But again, this definition, this derivation is not needed. So people who are not into mathematics do not have to worry about it. So if your input, like in this case, I is doubling, or your the whole input, whole your search, whole your list is getting half every time, then you can assume that it is log of n. Okay, for I will show another example also quickly. So how many of you have heard about this thing called binary search? You can raise hand or you can type yes. So just participate. If you really participate, then I am assuring you that, okay, at the end of the series, you'll be very good with Java data structures, algorithms, and even we'll be doing live projects, you'll be good with all of these things, but only if you participate. Okay, so in binary search, so in normal search, what was the time complexity worst case? So if you have some random list such as 1, 5, 3, 7, etc., etc. So what was the worst case? It will be always n. In worst case, you'll have to check for n. And in case of binary search, the list is already sorted. Sorted means it will be 1, 2, 3, 5, 7, 9. And then if you want to search for a number, say you want to search for 9. Okay, so or we'll have 10 here. Okay, so if you want to search for 9 or 10, in so if it is 10, in if it was a normal search, then it will take 10 If you are doing a normal search, it will take 10 comparisons. You compare with one. So number of comparisons will tell you the order, right? So you will check with 1, 2, 3, 5, 7, 9, 10. So in worst case, it will be 1, 2, 3, 4, 5, 6, 7. So in worst case, it will be 7 comparisons, and which means it will be order of n. But in binary search, what they do is you will directly go to the middle element, and see if 5 is or middle element is equal to the what we need 10, right? Is middle element equal to 10? No. If the middle element is not equal to 10, then we will see whether this 10 is greater than 5 or less than 5. If 10 is greater than 5, then answer could be only in this side, right? So immediately we will strike off half of the list from our comparison plan. So next we will because imagine, so this could be a very big list. So next we will go, so this will be the next list, input list. So now we have divided the list in as 2. Half of it is discarded. So now we will look into the middle element here. If middle element, if in this case you cannot take a middle element, so you will take one to the right or left, and then you will check. Okay, if you have selected 9, you will check. Okay, is 10 equal to 9? No, but 10 is greater than 9. So you will again cut off this part. Okay, so now the next step you will get into 10. So basically in binary search, in every iteration, half of the list is removed from our comparison plan. So it is very similar to this case, right? So here I is jumping, getting multiplied. So it is doubling every time, and here the list itself is getting half every time. So effectively both of them will take approximately same time. And in such cases, either if the input variable is doubling, or if the list itself is getting half in every iteration, then you can assume for now that it is going to be log n. Okay, so this is just for people who are afraid that you are not good in mathematics or you do not know mathematics. But again, I take a lot of interviews every day, but there are many people who does not even know about it and still get selected, because it is, you need to have a basic understanding of these things. And then if you really become an expert in all these things, then you can explore more, and then with experience you will learn a lot more. Okay, so for now, except for the small confusion with respect to logarithm, are you clear with the order? At least the order you are clear. Are you clear with the order? The order of 1, or order of log n, order of n log n, n square, n cube, and c raised to n. Yes? Okay, if your answer is yes, then we are good. Okay, so again, of n log n is a little more complex. So once we have little more knowledge, we will look into those things. So things such as a merge sort. So it is little more complex. Okay, so if you look into sorts such as merge sort and all, that will be order of n log n. But again, so since we have people who are completely new to programming, so you will not understand complex logics now, but we will definitely come to it. And one more thing, if you have so if you have something, a equation of the kind order of n square plus order of n plus order of 1. So generally you will ignore the smaller ones and mention the order as order of n square. So whatever is the highest. Okay, so this thought of mentioning that also. So are we good? All clear until now? Yes. Okay, so that is very perfect because normally people take time to understand these things, especially people who are new to programming. But Interestingly, everybody has understood it. That is a very good sign. And now, whenever we do programming, whenever there is a question, I am good in maths but never done coding, will it take time? Absolutely no. If you are good in maths, then you can learn coding much faster. But again, you don't have to mix maths, and then there will be some problems that involve maths. Then those knowledge will help. But otherwise, coding anybody can learn. The only thing is you have to put effort. Okay, there is a question: will we learn Java from scratch? Definitely, we will learn Java from the very scratch. Whenever you feel like questioning yourself whether you can learn programming or not, just tell one thing to yourself, that any programmer you see around, including me, any programmer that you see around, including me, once never knew anything about programming. Okay, if these people, including me, can learn, you can also learn. Okay, so nobody has born with programming skills, right? So if others can learn, you can also learn. And as you know, the development has the most number of jobs compared to any other job opportunity. So it is a very safe bet. And if you are not able to follow, or if your interest lies in something else like DevOps or security, true interest, not because if you are not able to follow, then it makes sense to go to the other streams. But otherwise, it always makes sense to at least give it a try. Okay, so if you are giving up without giving a try, then that is definitely going to be bad. And if you are going to give a try, then I will do my best to make sure that you learn programming, you start thinking about solving problems, and then you will also solve problems. Because I have taught students from school, because these days students have programming classes in school, Java classes in school. So in 8th, 9th, and 10th, if they can learn Java, so working professionals like you all, it will be just a piece of cake, right? But you have not tried before, then there is no excuse. You have to try, and we can discuss personally. If you are not able to follow, then I will help you personally, and we can learn together, and then we can grow together. So before actually diving into Java, and before actually practicing Java related things, I thought let us start from algorithms, and then slowly after we learn a little bit of Java, then I will also talk about data structures. So I will keep the part 2 of this later. So like in movie series and all, so the TV series and all, you see, right? So some when you have very serious villains and all, you have your part 1, and then after that there will be some smaller normalcy episodes, and then you will have your part 2 where your villain will be actually caught. Okay, so our data structures and algorithms part 2 will most probably happen after we learn a little bit of Java, so that you'll be in a better position to implement those data structures using Java. So we will implement those data structures. For example, we have data structures such as hash map and all. Many people get because last day itself I saw some query in our own Java WhatsApp group, that somebody got an interview question to implement hash map on your own, because hash map is something which is there in Java by default, but if you want to implement it on your own, so those things and many other things will be learning going forward. So participate well, practice regularly, and ask if you have any doubt at all. So do you agree? I need an yes or no in the chat, and then we can wind up. So if you are part of any of the WhatsApp group, you will know my number. So you can just message me whatever I am going to ping you. So I always prefer to know, okay, who all stay till the end whenever it is in a webinar mode. Just message me directly, WhatsApp me, and I will get back to you with something good. Even otherwise, you will be in my good books, so that whenever you have a issue, whenever you have some doubts, because I am also working and I also have a lot of things, but I will try to prioritize, because I know that, okay, you have stayed till the end, and for that I will definitely try to prioritize your cases. Okay, so do message me. Final question, as I always ask, was this session useful to you? You can mention yes or no or whatever it is, and then we can find out. Thank you. So if you are if it was useful, you can mention in the group also, so that people will come forward, because many people are not coming forward because they are afraid of programming. Okay, but let us make things simpler, and then let us learn together, and then let us make things much simpler. Okay, so thank you all for attending, and see you all soon. And until then, bye bye.